Assalamualaikum warahmatullahi wabarakatuh, students. And this is your first physics video for your online learning. Before the holiday, we started with Unit 2, Kinematics. And in this unit, you learned about speed, you learned about velocity, you learned about acceleration, and distance and displacement. And then after you learn about all those things, you learn about graphs. So I hope you still remember the things that you learned before the holiday, especially with graphs. Now for this term 2, we're gonna start with the next part of the topic. The next part of the topic is about something that we call free fall. Okay, it's actually a small topic, but for the time being, for this week, we're just going to go through the first part of this topic. So the first part of this topic is this here, falling under gravity. So what are you going to learn in this video? So these are learning objectives for this video. So what you will learn is you will learn about the name of the force of attraction that is pointing towards the Earth. You will learn about what we mean by free fall, and then you will learn about what we mean by acceleration due to gravity. And then afterwards, towards the end of the video, we will look at the factors affecting the acceleration due to gravity. Okay, so for this video, what you need is your notes. So I'm pretty sure I've given out your notes. You can find your notes in your home learning pack. And then while you are watching this video, make sure you have the notes ready, make sure you have a highlighter ready, and make sure you have a pencil ready, so that if there is any important information that is coming up from this video, you might want to write it down straight to your notes, or you might want to highlight some key information or key words in your notes while watching this video. Okay? So in this video, I'll use two things. I'll use the slide, and I'll also use the whiteboard. Okay, so there will be two different views, one for the PowerPoint slides, and then one for the whiteboard. Okay, so we're gonna head towards the slides. So I have my laptop here with me, and we're gonna talk about the slides afterwards.
Right, so like I said, we are still in chapter 2 of the syllabus, and in this chapter there are basically 3 parts. The first part is all about distance, displacement, speed, velocity, and acceleration. So we've done that. The second part is all about graphs. So I hope you still remember what you learned last time. And then we're going to look at the third part in this lesson. Okay. So like I said, the third part is about free. Right. So before we start the topic, have you ever wondered these things? So have you ever wondered what causes objects to fall? What happens when an object falls? What are sort of forces that are acting on the object when it's falling? How is it falling? Is it falling faster and faster, or is it falling slower and slower? Does it stop, or does it go on? Well, what happens when people go skydiving? And this topic will also explain how do cats survive falls from high heights. So we will look at all of these things in this topic. Right, so free fall. As you all know, pretty sure all of you know that whenever things are falling, it's falling because of this force that we call gravity. And gravity, what we mean by gravity is the pull of the earth, and it's a type of force. So sometimes we call this force gravity, okay, but sometimes we call it gravitational, okay, I'm sorry for my handwriting, but all of you are used to this already, right? So sometimes we call it gravity and sometimes we call it gravitational force. That is the much more scientific name for gravity. Please do not call it gravity force, because in physics there's no such thing. Please use the proper word when you are talking about gravity. Either say gravity or say gravitational force. There's no such thing as gravity force. Okay, it's not grammatically correct. And an object is free falling if it is falling under the sole influence of gravity. Okay, we say, right? So
Right, so you have a ball falling. Okay, so this is a ball. It's falling, and gravity is pulling it down towards the earth. And if only gravity is acting on this ball while it's falling, then we say this object is falling. This object is free falling. Okay. If there is a different force acting on it, let's say, for example, there's another force here that is acting on the ball while it's falling, right? That is, we don't consider the ball as under free fall. Okay. So free fall, what do we mean by free fall? Free fall means only gravity is acting on it. All right.
So the thing that you need to know when objects are falling due to free fall is that they all have the same acceleration. And this acceleration is 10 meters per second squared, right? So all objects, no matter what's the size, the shape, or how heavy it is, it always falls at 10 meters per second on Earth, right? So this is on Earth, always 10 meters per second. And this acceleration is called the acceleration due to gravity. This acceleration depends on two factors. The first is the altitude, so the height where the object started to fall. So if the object is falling from a higher altitude, then it will have a smaller acceleration due to gravity. If it's falling closer to the ground, then it will have a larger acceleration due to gravity. Okay, so what do I mean by that?
Right, so this is, let's say this is the ground, and you have an object here falling at a height of, let's say, 10 meters, right? And for an object falling at 10 meters, it will have an acceleration of 10 meters per second squared. Okay, this acceleration is true for all objects, all free falling objects, no matter what's the size, no matter what's the mass of the object. Right? Let's say you have this is object A. Let's say you have a different object, also free falling, and this object is much higher at a higher altitude. So let's say this is 100,000 meters. Right, that's quite high. But this object, because it's at a higher altitude, it will have a smaller acceleration due to gravity. So the acceleration for this object B, will be probably about, let's say, I'm just giving up random numbers here, 8 meters per second squared. Okay? So the acceleration due to gravity depends on the altitude of which the object is falling.
And it also depends on the gravitational field strength. So the gravitational field strength is basically a quantity that tells you how strong the gravity is for that planet. So if you're on the moon, so let me just read this out for you. The gravitational field strength of the moon is weaker than the Earth. Then that means if you drop objects on the moon, the object will fall with a smaller gravity than on Earth. In fact, I'm pretty sure you can see here on the moon, the acceleration due to gravity is 1.6 meters per second squared, while on Earth it is 10 meters per second squared. So that's Earth's, sorry for my handwriting. So that's the Earth's acceleration due to gravity, and that is always true for all objects free falling on the Earth, while on the moon, objects will fall at this acceleration for all objects that are that is free falling on the moon. Okay. The other thing that I want to inform you, this number here, the true value for this number here is actually 9.8 meters per second squared. So that is actually the true value for the acceleration due to gravity on Earth. But for your syllabus, we're just gonna round off this number to 10 meters per second squared. Okay. So when you go to sixth form, you might use this value, this true value here, 9.8 meters per second square. But for your syllabus, for O levels, you will just use 10 meters per second square, which is the rounded off version of the true value for the acceleration due to gravity. Let me just read this out for you. Since all objects fall with the same acceleration, so if you drop two objects of different masses from the same height, it will reach the ground at the same time. So if you have two objects of different masses, okay, let's say I have my marker here and I have my phone. So if you drop them together, in theory, they will reach the ground at the same time. Okay, so I won't do this because my phone is very precious. Um, so they should reach the ground at the same time. Now I cannot show you this in this video, but I shared you a link to a different video, and make sure you watch that video, and it will show you and it will explain to you this thing. Okay, so objects will fall at the same rate and they will reach the ground at the same time. Okay, but of course this doesn't happen in real life, right? If you have two objects, let's say you have a tissue and you have a bowling ball.
So if you have two objects, let's say you have a tissue. Yeah, that's a tissue. And then if you have a bowling ball, okay, you ask a person, or you try to decide which one will reach the ground first. Of course, it's the bowling ball. The bowling ball will reach the ground first. But if these two objects are in free fall, meaning there's only gravity acting on it, what should happen is that both of these will reach the ground at the same time. The reason why they do not reach the ground at the same time is because of one thing. It's because of air resistance. So we'll talk about air resistance next week. So just to give you a brief explanation, what is air resistance? Air resistance is basically the force exerted by the air when we are going through it. Okay, so if you put your hands, when you are driving a car, you put your hands outside of the window, you can feel the air, the wind pushing back against you. That is air resistance. So when you are falling, pretty sure you all can imagine this. When you are falling, you can feel the air pushing back against you, and that is air resistance. Okay, so the reason why the tissue is falling slower is because it has a bigger resistance, whereas for the bowling ball, it has a small air resistance, and the air resistance is what's causing the tissue to fall at slower than the bowling ball, right? I want to explain again that during free fall, we only have gravity acting on these objects. During free fall, their acceleration is the same, which is on Earth. If it's on Earth, it should be 10 meters per second squared. But because you have a different force acting on them, so they're not truly in free fall, and therefore their acceleration will be different. Okay, and therefore they won't reach the ground at the same time. So if you, I gave you the links to the video. So if you watch the videos that I shared with you, that they will explain better what I mean by these things. Right? Things fall at a different rate because of air resistance. So in theory, if you don't have air resistance, these things will fall at the same time. For example, if you drop these two things on the moon, there's a video showing two different objects, one heavy, one light. They're being dropped at the moon and they reach the ground at the same time. So please make sure you check out that video. Either you can ask me to share you the link to the video, or you can just look it up online on YouTube. So if you bring these two objects on the moon, the moon doesn't have an atmosphere, it doesn't have air, so there won't be air resistance on the moon. So if you bring these two objects on the moon and then drop them from the same height, they will reach the ground at the same time. Okay? Because they are both free falling and they both have the same acceleration, regardless of the size and regardless of the mass. So to recap, we learned about free fall. The first thing we learned about in this video is what is the name of the force that is acting on a falling object. The name of the force is gravity or gravitational force. Okay. And then the next thing that we learn, what is free fall? Free fall is when a falling object falls with only gravity acting on it. Okay? So if there's when an object is falling and only gravity is acting on the object, then we say the object is falling in free fall. Number three, what we learn is for objects in free fall, they all have the same acceleration. And we call this acceleration due to gravity. And for the Earth, the acceleration due to gravity on the Earth is 10 meters per second. And this is the same for all objects falling with free fall on Earth. So make sure you remember this number for your exams. And then the last thing that we learn is what are the factors affecting free fall. So there are two factors affecting free fall. So there's the altitude, and the other one is gravitational force. Gravitational field strength affects. Okay. So the higher the object, the smaller the acceleration due to gravity of the object. And if you drop the object on a different planet with a weaker gravitational field strength, then the object will fall with the smallest acceleration due to gravity. Okay, so these are basically the things that we covered today. So we're going to stop here today, and we're going to continue next week. So assalamualaikum warahmatullahi wabarakatuh, and thank you for watching this video.